Hello class. So today we're talking about our sky, right? Our sky. Night sky, we can see the stars. Day sky, well, we can't see the stars, but they're still there, right? It's just that the sunlight has obscured the stars because the sun's too bright. So we're going to be talking about mapping the night sky, right? We're all used to maps, right? Here's my phone. So I have Google Maps, right? Here's Google Maps. Here's a picture of the United States on Google Maps. Hopefully you can see that. But y'all know what I mean, right? It might be a glare, but it's a picture, right? So, you know, we have our globe. The globe is divided into countries. Countries are divided into states. Our states are divided into counties. We have cities, towns, right? So we divvy up the space, right? We divvy it up. And then it's a map. We can find our way around. When you're using Google Maps, you hold the phone like this, and you'll go to where you want to go. I'm walking to this place, or you're driving to a place, right? Your phone is like this, but it's on the ground. You're going in this direction. You're going north, south, east, or west, right? When you have a map of the sky, of course, if you and there are apps you can get. We have a map of the sky. How would you hold the phone? Well, you'd hold the phone like this, because you're looking at the sky, right? So it's up above your head. So keep that in mind. So an ancient way that a lot of people map the sky is constellations, right? Now we have our set of constellations that we're used to in the West. We have you have your birth signs, right? I'm a Cancer, people are a Scorpius or Virgo, what have you. There's other constellations up there. So we're used to this method, right? Other cultures, they have their own constellations. There's a homework assignment where you have to read an article about that. So it's up there. So what happened is, but there's also empty spaces, right? There's some regions where the constellations didn't quite fill in all the spaces. In the 1920s, scientists got together, astronomers got together, a worldwide body, and they divided the sky into 88 regions. That's 88 regions. And they still call those constellations. The definition's a little bit different. You know, constellations used to mean a pattern of stars that the ancients thought looked like something, be it a lion or a bull, right? Taurus was a bull. Scorpius was a scorpion, right? They divided the region into 88, or divided space into 88 regions, and that's the globe. So we have Earth, so it's the entire sky, wherever you look down Earth. There's 88 regions. And those are constellations. So the modern definition of a constellation is those 88 regions, and all of the sky is included. Every object that's in the sky is in one of those 88 regions, right? So that's the modern definition of a constellation, right? Test question, that's going to be on the test, right? So the sky is divided into 88 regions, and there's modern ones, right? Like there's a constellation called Microscorpius, right? Well, it was named after a microscope, which was, in the 1920s, microscopes were more of a big deal. In the ancient times, they didn't have microscopes, right? So that was one of the constellations that they used, where it's a modern name, to fill in the spaces in the sky that the system we use of constellations didn't account for all that, right? So let's take a look just at a picture of that. Quickly, so here is, okay. So here, in the ancients, here's a picture of a fish, right? Here's a picture, sort of a person, and they had so Pisces was a fish, Taurus was a bull, Scorpius, right? So they had regions of the sky that they named, and that would help them in navigation, right? There was no light pollution back then. You didn't have street lights. Unless it was cloudy, you could see the sky. That helped them with their navigation, right? So, and then these days what they've done, what astronomers did, is they drew lines around all the constellations. So Andromeda is a constellation. And just like our states, just like in the US, you know, few states are perfect squares. The borders can be quite rough also for countries. The constellations are the same. Pegasus is this very rough outline Andromeda. And this is based on the ancient systems because people were already used to that. That system already worked well. They just refined it. Okay? So that is a constellation. Now there's something different, right? We're familiar with, there's a lot of objects in the sky that look like things, but they're not constellations. A famous one is the Big Dipper. I talk about the Big Dipper in another video in this module. It looks like a cup with a handle on it, but it's not one of the official constellations. It's just a pattern of stars that looks like something. You can have your own asterism. For instance, you know, you could have a pattern of stars that looks like your Uncle Joe, right? So oh, there's the Uncle Joe pattern, right? So you can make up your own asterisms, right? Do I have asterism? Yeah, so right here, asterism. In observational astronomy, an asterism is a popular known pattern or group of stars, right? So there is asterism. Okay. Let's talk about something else, right? When you look at the sky, some stars are extremely bright, others are very dim, of course. Now the dim ones, well, we're not sure, you know, are they brighter stars or are they stars that are just farther away? Well, from Earth, we have a magnitude scale, and we're just talking about how bright do the stars look for us. Later on, we're going to talk about how bright the stars actually are. Now we're just going to talk about how bright the stars look to us. Well, this scale, the origins of this scale were actually developed thousands of years ago. A gentleman named Hipparchus developed this, where he had the brightest stars. The brightest stars started at 1, and then as they got dimmer, they had greatest numbers. Well, that might sound okay, but think about it. Usually the way we do things is when things are brighter, they would have bigger numbers. So this scale is kind of backwards in that the smaller numbers are actually brighter. So Polaris, that's the North Star, it's very bright. It is brighter than a lot of other stars that have bigger numbers, right? So the naked eye, we can only see stars up to about a 6 with our naked eye. But once we pull telescopes out, we can see a lot more stars. The Hubble Space Telescope, right, that's a telescope that's orbiting Earth. It's been up there about 30 years now. It can see stars to magnitude 30, right? 30 is a bigger number. These stars are dimmer than stars we can see with our naked eye. In fact, what happens is that the scale actually goes negative. We're Sirius. Sirius is the brightest star in our sky. It actually has a negative number. Venus, we can see the planet Venus. It's often you see it either in the morning or in the evening as the sun sets, because it's closer to the sun, so it orbits the sun. So when the sun rises or sets, that's when we tend to see Venus. It is very bright. It has a number of -4 point something, right? The moon, we know the moon is a big, huge, bright object in the sky when it's out there, right? It's about a -12. The sun is about a -27, 26 and a half, right? So it's called a parent magnitude. That is how we classify the brightness of objects in our night sky. It's based on a system that's been around for thousands of years. Yes, scientists have been around for a long time. And there we have it.